Welcome to the Deep Dive. This is where we really dig into a topic, take all the information, and try to pull out what's truly essential, maybe surprising, and hopefully insightful for you. Today, we're looking at an object that's just fascinating. It sits right at the intersection of, well, luxury goods, high-end engineering, and frankly, the future of space exploration.
It's quite something.
Yeah. So when you think Omega and space, your mind probably jumps straight to the Moonwatch, right?
The Speedmaster Professional.
Yeah.
Iconic.
Exactly. The first watch on the moon, NASA certified. I mean, that sets an incredibly high bar.
Yeah.
It's got this amazing heritage.
Mm-hmm.
So our mission today is to explore Omega's next step, you could say, the Speedmaster X-33 Marstimer. We want to unpack how this watch, which is analog and digital, is built specifically for Mars. Not just Earth, but for that really challenging, unique environment.
Mm.
And what does that tell us about, getting ready for humanity's next big leap? What kind of clever thinking does it take to make something work on two different worlds?
It's a really extraordinary piece of engineering, And what's fascinating is that this wasn't just some concept piece sitting in a lab. The Marstimer, which came out in 2022, was actually developed in partnership, a direct partnership between Omega and the European Space Agency, ESA.
ESA.
Yeah. So it's not just about Omega extending its brand, though obviously there's that connection. It really highlights how much collaboration is needed, even for what might seem like a small part of the bigger picture of space travel.
Okay, let's dig into that then, because getting to Mars is one thing, but living there, working there, that brings up challenges we probably don't even think about here on Earth, like just time itself. I mean, I assume a watch built for Mars has to be incredibly tough, right? What materials, what design choices make it able to survive out there?
Precisely. Survivability is challenge number one for any equipment, really, for Martian pioneers. So this watch has a 45-millimeter case, and it's made from grade 5 titanium.
Grade 5 titanium?
Yeah.
Okay.
And this isn't just about being robust, though it is. It connects right back to that Moonwatch legacy, using really cutting-edge materials for the job. Just like Apollo needed new stuff, new alloys for vacuum and temperature swings, Mars needs materials that can handle its own extremes, the heat, the cold, radiation, and doing it all without being too heavy.
Yeah, that makes perfect sense. Every single gram counts when you're talking space travel.
Right.
But okay, beyond just being tough, the main job of a watch is keeping time accurately. And I know a day on Mars isn't quite the same length as ours. How does the Marstimer handle that?
That's really the core of it. Inside, it has a specially developed movement. It's a thermo-compensated quartz movement, the caliber 56222.
Thermo-compensated. What does that mean exactly?
It means the movement actively adjusts itself to counter the effects of temperature changes, which is vital for Mars. You're talking about temperature swings of potentially hundreds of degrees Fahrenheit between Martian day and night. A standard quartz watch, it would just get thrown way off. It'd become useless for anything precise. This ensures it stays incredibly accurate, no matter how hot or cold it gets.
So it's not just strong, it's smart about temperature. That's clever.
Yeah.
And then there's that day length thing you mentioned, the Martian day, the sol, right?
The sol, exactly. It's about 39 minutes longer than an Earth day.
39 minutes. That doesn't sound like much, but I guess it adds up quickly.
It absolutely does. And that's why the Marstimer includes a specific function for Martian Time Coordinated, or MTC. This function tracks the time and date on Mars, specifically at Mars's prime meridian relative to Earth.
Okay, MTC.
Think about coordinating complex tasks, a rover doing something, an astronaut needing to meet it, if your clocks are drifting apart by 39 minutes every single day.
Yeah, that sounds like a recipe for disaster, or at least massive confusion and wasted resources.
Exactly. It's a fundamental problem of working off-world. This watch helps solve that potential chaos, just quietly doing its job.
That's a critical detail. It saves you doing mental gymnastics all day, or missing your Martian dinner bell by nearly 40 minutes every day. Yeah. So besides keeping Earth time and Mars time straight, what else does it do? Are there other tools built in that would be vital on another planet? Navigation, maybe?
That's a great question. How do you find your way around on a planet with no GPS? Well, the Marstimer also includes a solar compass. It's pretty ingenious.
A solar compass. How does that work?
You point the watch's hour hand towards the sun, factor in the time, and it can help you find true north. But here's the really clever bit. It's calibrated to work accurately on both Earth and Mars. It accounts for the different day lengths, the different axial tilts, everything.
For both planets. That's seriously impressive engineering. Vital for surface navigation, I'd imagine.
Definitely. For future astronauts moving around on the surface.
But hang on, what about Mars's famous dust storms? They could block out the sun for weeks, right? Would the solar compass still work then? or their backups?
That's a very sharp point. And you're right, during a major dust storm, a solar compass would be, well, useless. Any long mission would absolutely rely on multiple navigation systems. Redundancy is key. Inertial systems, maybe star trackers when possible. The watch is one tool in the kit. It gives you that immediate ground-level orientation when you can see the sun.
Okay, part of a bigger toolkit. Makes sense.
And speaking of how it looks, the design choices aren't just for show either, are they? They tie back into the function, the environment.
They definitely seem to. That reddish color you see on the bezel,
Yeah.
the outer ring, and on the second hand.
The sort of rusty red.
Yeah, that anodized aluminum. It's colored to look like red hematite, which is, a direct nod to the red dust, the color of Mars itself. It ties the whole design back to its purpose.
Absolutely. And that functional detail goes right down to its physical dimensions. It's about 14.9 millimeter thick.
Which sounds pretty thick for a watch.
It is, but it needs to be to house that complex movement. But it's also designed ergonomically to still fit under the cuff of a spacesuit. That's a real consideration.
All right. Practicality.
And even the water resistance, 30 meters, that sounds low for a modern dive watch, maybe. But on Mars, it's not about deep-sea diving. It's about protecting the movement from fine dust getting in and potentially from condensation if you move between different pressures or temperatures. Again, it's tailored for that environment. Every little detail serves a purpose.
So wrapping this up then, what does this all mean for us back here on Earth? This watch, the Omega Speedmaster X-33 Marstimer, it really is this incredible mix, isn't it? Fine watchmaking, luxury, but packed with engineering aimed squarely at deep space. It sits here on Earth as a luxury item, sure, but it kind of embodies that human drive, that aspiration to actually get to Mars.
It really does. And, it leaves us with a pretty provocative thought, something for you, the listener, to maybe mull over. If something as seemingly simple, as personal as a watch needs this much rethinking, this level of reengineering, even a partnership with a space agency, just to work properly on another planet, well, what does that tell us about everything else we use every day? All the objects we just take for granted? If humanity ever does set up a permanent base somewhere like Mars, what other mundane items might need that same kind of radical ingenuity? Your kitchen kettle, your phone, your shoes. How do you bridge that gap between two worlds for everyday things? And maybe even more interesting, could figuring that out actually teach us something new about design and usefulness right back here on Earth?